So now we're going to look at the remainder theorem, which is kind of this bigger rule that the factor theorem is part of. So here we have a problem. It says if f of x equals 5x squared minus x plus 2, then what is the remainder when f of x is divided by x plus 1? So first off, if we were checking to see if x plus 1 was a factor, then we would expect f of negative 1 to equal 0. We would expect with polynomial long division that there would be no remainder, or the remainder would be 0. So the whole idea here is that remainder matches this function value. So if the f of negative 1 is not 0, whatever it is, that's how much off it is from being a factor. Let's say it's 5 off, like that value is 5, it's 5 away from being a factor. So that away from is also the remainder. So here I have f of x graphed. And if we're trying to look at x plus 1, thinking about dividing by x plus 1, on the graph, once again, we will check negative 1. So here that is. So negative 1 is not a factor. It's 8 off, which means the remainder, if we did the whole long division, that remainder, the amount off it is from being a factor, is 8. So I have the polynomial long division down here. If I scroll down, I did the 5x squared minus x plus 2 divided by x plus 1. I got 5x minus 6. This will never be given with the remainder theorem, but we can know that the remainder is 8. So that's kind of a quick way to do things. It's also a great way to check. And that's why I have this little note here. I thought it was something I would talk about in class. It says silly mistakes. I'm not sure if you can see it, but somewhere in here I had to erase, and the scanning the PDF kind of got rid of that. But I made a mistake the first time I did the problem above and had to erase to fix it. How did I catch my mistake? The remainder theorem. So since I knew from the remainder theorem that this remainder should be 8, when I didn't get an 8, I knew that I was wrong and I had to go back and check it. So if you think you make a lot of silly mistakes in algebra, everyone does. We all make mistakes. There's a lot of little steps. Just remember there are almost always 2 ways to do a problem or a different way to check your answer. The people who seem to never make silly mistakes, so you're like, I make silly mistakes, but this person always gets everything right. They probably just know multiple ways to check their work, and they use those ways to check it. So think about that. Find these ways, like there's always ways to kind of work in a different direction to see if your algebra is correct. So to summarize our remainder theorem, if a polynomial p of x, once again use the p's just to kind of match this p, is divided by x minus a, so let's say we divide by x minus 2 again, the remainder is equal to p of a. So that function evaluated at positive 2, right? Change the sign. So what this means basically is if you divide by binomial, and we'll talk about this in a little bit. It has to be a linear binomial, so I'm going to add that. If we divided by x squared plus 2, this wouldn't work the same way. If it's not a linear or x to the first. By a linear binomial, you can check the table at the opposite value. To find the remainder, which will be that y value. So just like we saw on the top one, that 8 was that y value, that was the remainder. Okay, that's basically what we were doing. So now the factor theorem is a special instance of the remainder theorem, but we're specifically looking for 0, not some other number. So we have a couple practice ones, and we'll bring up the calculator and look at those. So my next one, the next page, says 2x to the 4th minus 1 is by f of x. What's the remainder when it's divided by x minus 2? So we'll look at that Desmos calculator. Minimize it here. Now, a lot of them on Delta Math are like this. Basically, I just have to go back, and it's going to get rid of some things. Let's see. Look at the expression. We're going to close out this one and put a new one in. So I'm going to type 2x to the 4th minus 1. So this is still a polynomial function, just less terms. And a lot of them, as I said, are like that on Delta Math. So now I'm going to go to my table. I want to know the remainder when I divide by x minus 2, so I'm going to check my table at 2. So I can see it's 31 down here, but I could also type in 2 up here, and it will show me that 31. So 2 happens to be in the equation. So if I go back up here and write that, to find just the remainder when I divide by x minus 2, I'm doing f of 2, which equals 31. So if we did the polynomial long division and we set this up, we would have 31 left. So our next one, 3x cubed minus 4x minus 1. And I would pause and try this just to make sure you're good with it. And you can do it on a graphing calculator too. This is just a little easier for the videos. And this time, what is the remainder when we divide by x plus 3? So I'm going to check my table at -3. I'm going to type a -3 in here. So the remainder would be -70. So just to not go too fast here, f of -3 is -70. So now we're going to connect this a little bit more to the polynomial long division that we were doing before. This one says, what is the result when 4x cubed plus 18x squared plus 17x minus 16 is divided by x plus 2? So I need the whole result. So the remainder theorem is not going to get me the answer. But now that I know the remainder theorem, I would always use that in the very beginning to kind of see what I'm aiming for. So I'm going to type in this as a function, okay, what we're seeing what it goes into. So that's 4x to the third plus 18x squared plus 17x minus 16. So I'm going to evaluate the function at -2. And we already have it right here, so it's -10. So that means when I do this long division, I should get -10 as the remainder. So let's go ahead and do that long division. So that's what we're expecting, right? So I'm saying how many times does x go into 4x cubed? And I'm going to do this kind of quickly on this video. So that's 4x squared times, and then we're going to multiply. So 4x cubed plus 8x squared, subtract, and we'll change our signs, right? Make an addition and change these two. Cancels, 18x squared minus 8x squared is 10x squared, and we bring down the 17x. X goes into 10x squared, right? 10x times. So now we're going to multiply, and that gives me 10x squared. 2 times 10x is plus 20x. So now I'm going to subtract and change my signs. So 17 minus 20 is -3x here. Remember, this cancels. And we're going to bring down the 16. Okay, so now how many times does x go into -3x? That's -3 times. Multiply it out, -3x. 2 times -3 is -6. Change the signs. -16 plus 6 is -10. So because I wanted my remainder to be -10, I mean, maybe I made some mistake that miraculously I got a remainder of -10 and there's some mistake in there still, but probably not. So this question also asks to write it in that quotient remainder form. So my answer is 4x squared plus 10x minus 3. Make this a little bigger so I can get that in there. And then my remainder is -10, so plus -10 over x plus 2. So the last little thing that's going to go on this video is just some comments, and that's right here at the top, the note. So I just want to talk about this. If you are dividing by a binomial such as 2x plus 1, if I set that equal to 0 as if it was a factor, I would get negative 1/2. Now I can use that, so you could evaluate the function p of x at negative 1/2 to use the remainder theorem. So it works with those binomials that have a coefficient in front of the x. If you are dividing by a quadratic, like this is what you're dividing by, we saw some of those, the remainder theorem will not work. The divisor must be linear. So you have to have just an x to the first in what you're dividing by, which means that power of x must be 1. So that's just something to think about, and then the next video will have the last set of questions.